The ingenious design of the aluminum beverage can.
Every year, nearly 500 billion of these cans are manufactured. That's about 15,000 per second. So many that we overlook the can's superb engineering. Let's start with why the can is shaped like it is. Why a cylinder? An engineer might like to make a spherical can. It has the smallest surface area for a given volume, and so it uses the least amount of material. And it also has no corners, and so no weak points, because the pressure in the can uniformly stresses the walls. But a sphere is not practical to manufacture, and of course, it'll roll off the table. Also, when packed as closely as possible, only 74% of the total volume is taken up by the product. The other 26% is void space, which goes unused when transporting the cans or in a store display. An engineer could solve this problem by making a cuboid-shaped can. It sits on a table, but it's uncomfortable to hold and awkward to drink from. And while easier to manufacture than a sphere, these edges are weak points and require very thick walls. But the cuboid surpasses the sphere in packing efficiency. It has almost no wasted space, although at the sacrifice of using more surface area to contain the same volume as the sphere. So, to create a can, engineers use a cylinder, which has elements of both shapes. From the top, it's like a sphere, and from the side, it's like a cuboid. A cylinder has a maximum packing factor of about 91%, not as good as the cuboid, but better than the sphere. Most important of all, the cylinder can be rapidly manufactured. The can begins as this disc called a blank, punched from an aluminum sheet about 3/10 of a millimeter thick. The first step starts with a drawing die, on which sits the blank and then a blank holder that rests on top. We'll look at a slice of the die so we can see what's happening. A cylindrical punch presses down on the die, forming the blank into a cup. This process is called drawing. This cup is about 88 millimeters in diameter, larger than the final can, so it's redrawn. That process starts with this wide cup and uses another cylindrical punch and a redrawing die. The punch presses the cup through the redrawing die and transforms it into a cup with a narrower diameter, which is a bit taller. This redrawn cup is now the final diameter of the can, 65 millimeters, but it's not yet tall enough. A punch pushes this redrawn cup through an ironing ring. The cup stays the same diameter as it becomes taller and the walls thinner. If we watch this process again up close, you see the initial thick wall and then the thinner wall after it's ironed. Ironing occurs in 3 stages, each progressively making the walls thinner and the can taller. After the cup is ironed, the dome on the bottom is formed. This requires a convex doming tool and a punch with a matching concave indentation. As the punch presses the cup downward into the doming tool, the cup bottom then deforms into a dome. That dome reduces the amount of metal needed to manufacture the can. The dome bottom uses less material than if the bottom were flat. A dome is an arch revolved around its center. The curvature of the arch distributes some of the vertical load into horizontal forces, allowing a dome to withstand greater pressure than a flat beam. On the dome, you might notice 2 large numbers. These debossed numbers are engraved on the doming tool. The first number signifies the production line in the factory, and the second number signifies the body maker number. The body maker is the machine that performs the redrawing, ironing, and doming processes. These numbers help troubleshoot production problems in the factory. In that factory, the manufacturing of a can takes place at a tremendous rate. These last 3 steps, redrawing, ironing, and doming, all happen in one continuous stroke in only a 1/7 of a second. The punch moves at a maximum velocity of 11 meters per second and experiences a maximum acceleration of 45 Gs. This process runs continuously for 6 months, or around 100 million cycles before the machine needs servicing. Now, if you look closely at the top of the can body, you see that the edges are wavy and uneven. These irregularities occur during the forming. To get a nice, even edge, about 6 millimeters is trimmed off of the top. With an even top, the can can now be sealed. But before that sealing occurs, a colorful design is printed on the outside. The term of art in the industry is decoration. The inside also gets a treatment. A spray-coated epoxy lacquer separates the can's contents from its aluminum walls. This prevents the drink from acquiring a metallic taste and also keeps acids in the beverage from dissolving the aluminum. The next step forms the can's neck.